So we are looking at example 2 now, and the question says, calculate the mass of oxygen produced if 2.45 grams of potassium triiochlorate 5 is completely decomposed by heating. The second part of the question says, how many moles of oxygen molecules are produced? And the last question says, what volume will this mass of oxygen gas occupy at STP? So looking at the first part of the question, to calculate the mass of oxygen gas that will be produced if 2.45 grams of potassium chlorate is completely decomposed. If you look at the question, now you observe that it is quite similar to what we just done in the first example. And in that example, we have our equation already balanced, and we have 2 moles of potassium chlorate against 3 moles of oxygen gas. But if you check the question, you will observe that in this question here, this example, we are interested in volume of oxygen gas. But now, the question wants us to calculate the mass of oxygen, not the volume of oxygen. So what we simply need to do is to say, from what we've calculated here before, 245 grams of potassium chlorate, that is to say, by the time we sum all this up, by the time we sum it up, 2 into 39 plus 35.5 plus 16 times 3. By the time we sum this up, we're going to have 245 grams of potassium chlorate, as against, in the first example, we did volume of oxygen. That is to say, we did 3 moles. This is 3 moles of oxygen gas. But now we are not interested in 3 moles because the question is not requiring us to find volume. But this time around, the question requires that we find the mass of oxygen gas that will be produced. So what we need to do is to also calculate the molar mass of the oxygen gas. So in this case, we have 3 into oxygen is 16, and we have 2 atoms of oxygen there. So this will be 16 times 2. And what we're going to have is 245 grams now, as against 3 into 16 times 2 is 32. And this is what it's going to give us. So 3 times 32 is 96. So what it simply means is that 245 grams of potassium chlorate will give us 96 grams of oxygen gas. So if that is the case, then the question from this second example says, if 2.45 grams of potassium chlorate is provided, then what mass of oxygen will be formed? Look at it. Calculate the mass of oxygen produced if 2.45 grams of potassium chlorate is completely decomposed. So what we need to say is, from the equation, 245 grams of potassium chlorate gives 96 grams of oxygen. Not like in the first example where we say 245 grams of potassium chlorate gives 3 moles of oxygen, because there we are interested in the volume of oxygen produced, not the mass of oxygen produced. And that is the essence of stoichiometry. Stoichiometry looks at volume, it looks at mass, it looks at mole. So either of these parameters may be required of us to find, whether volume, mass, or mole. So continue with what we have at hand. 245 grams of potassium chlorate produced 96 grams of oxygen gas. Now the thing is, if 2.45 grams of potassium chlorate is provided, what mass of oxygen will it give? Cross multiply, we have 245 grams times x will give us 2.45 times 96 grams. And there we have 245x is equal to 96 times 2.45, and that gives us 235.2. So to find our mass of oxygen, we need to divide both sides by 245, and when that is done, we're going to have 245 taking care of 245, and next we have our x value. What will be our x? X will therefore be 235.2 divide 245, and that will give us 0.96 grams. So it gives us 0.96 grams of oxygen. So what it simply means is that 0.96 grams of oxygen gas will be produced if we have 2.45 grams of potassium chlorate decomposed. So that is actually what our answer will be. So let us take a look at the solution. I just want to clarify that. So look at the solution so that you don't feel confused. So we have 245 grams of potassium chlorate giving us 96 grams of oxygen. And by the time we cross multiply, we have 0.96 grams of oxygen produced. So it's as simple as that. Now let's take a look at the second part of the question. The second part of the question says, how many moles of oxygen molecules are produced? How many moles? So let us take a look at how to calculate the moles of oxygen produced. We recall that moles, N, is equal to mass over molar mass. So if we recall that, it's simply to put the mass, which we just calculated the mass of oxygen to be 0.96, and we know the molar mass of oxygen is 32, so it's just to divide 0.96 by 32, and the moles of oxygen gas produced is 0.03. So the last part of the question says, what volume will this mass of oxygen gas occupy at STP? That is to say, that mass of oxygen, which is 0.96, what volume will it occupy at STP? 0.96, what volume will it occupy at STP? We are clear that 1 mole of any gas occupies 22.4 dm cube. It is a constant. 1 mole of any gas occupies 22.4 dm cube. Now, the last part of the question is saying, since we've calculated 0.96 gram of oxygen, what volume will it occupy? That is, what will be the volume of 0.96 grams of oxygen? That is the simple question. So what we need to do is, if we recall that 1 mole of a gas is occupying 22.4 dm cube, and 1 mole of oxygen, that is to say, if we simply write O2, when we write O2 is simply 1 mole of oxygen gas. We are talking about the last question, which is C part of it. O2 is simply 1 mole of oxygen gas, and 1 mole of oxygen gas is 32 grams because oxygen is 16, and since there are 2 atoms of oxygen, it will be 16 times 2. So this tells us that 1 mole of oxygen gas is 32 grams. So having seen that, it implies that 1 mole of oxygen gas is 32 grams and 1 mole of a gas occupies 22.4. So what it can actually tell us is 32 grams of oxygen is occupying 22.4 dm cube. So if that is the case, if 32 grams is occupying 22.4 dm cube, the question says, what will be the volume occupied? Look at it. What volume will this mass of oxygen gas occupy at STP? So if we have 32 grams occupying 22.4 dm cube, then the grams of oxygen, 0.96 gram, how many volume will it occupy? So it is just to simply cross multiply. By the time we cross multiply, we have our answer. So let us do that. Let us take a look at that. We have from the question, 1 mole of oxygen, that is 32 grams of oxygen gas, will always occupy 22.4 dm cube. That is 1 mole of oxygen gas. Then they said the mass of oxygen, how many volume will it occupy? That is 0.96. Now 0.96 gram, how many will it occupy? So let's take a look at what will 0.96 grams of oxygen occupy. So 0.96 grams of oxygen will occupy X volume. And when we cross multiply, we're going to have 32X. Is not clear. Our pen is skipping. Let us make that okay. So we have, let us clean that very well. Okay, we have this. So 32 grams times X is equal to 22. Okay, let's make that better. We have is equal to 22 times, we're going to make this, sorry about that. Let's make our pen. Let me do this. Okay. So we have, to cross multiply now, we have 32 times X is equal to 22.4 times 0.96. So 32 times X is 32X is equal to 22.4 times 0.96. That will give us 0.96 times 22.4 will give us 21.504. And when we divide both sides by 32, so 32 take care of 32, X therefore will be 21.504 divided 32. And that gives us 0.672 dm cubed. So that is our answer. So we can see that we are still in line. It is giving us almost the same thing as what we got in the previous example. So if we have 32 grams, which is 1 mole, it gives us 22.4 dm cubed. But 0.96 grams of oxygen will give us 0.672 dm cubed. So that is how to calculate, and that is our final answer. And I told you, if you're asked to take it to cm cube, we simply we simply multiply by 1000. And that will give us our answer in cm cube.